the squares, all the sides are of the same length. All of them are 7, so side times side. You know the area for number 1 here is going to be 49 units squared. For an equilateral triangle of side length 5, remember, with equilateral triangles, just use the 1/2 r squared sine of 60 degrees formula, and you can just do that in your calculator. Each of the sides is 5. So we end up with 10.8531755, and we round to 4 decimal places whenever we do not have any directions otherwise. So we've got 10.8253 units. And then lastly, a circle of diameter 10. Well, if the diameter is 10, that means the radius is 5. So we're going to go through pi r squared, 25 pi for our area. Alrighty. So what are we doing today? We're going to find the volume of a prism. And again, one of the things I want to remind you is that cylinders are prisms. You know, the base is a circle. It doesn't change how we feel about it, right? So as we're doing these, you know, we're going to spend extra time specifically on cylinders because we have the option to do so. But it's still the same exact problem. So let's begin just by bringing back those oblique ones we talked about like for 5 seconds last week. What's really important to note today, just like I said last week, is that these things are the same. All it's doing is leaning to the side, but it doesn't change. It doesn't change how much it can hold. So one of the things that they talk about here is something called Cavalieris Principle. You don't have to write that down, but like basically all it says is if you know every place along the way has that same cross-sectional area, and then if they have the same height, then they have the same volume all told, right? That's all that means. And so it doesn't matter what the shape is. It doesn't matter if it's leaning or standing up straight or whatever. If the cross-sectional area is the same all the way through, then it's going to be the same no matter what the figure is, right? So another way to think through this is with the formula that we're going to be using for today. The volume is equal to the area of the base times the height. So you know, thinking back to that last page, as long as the heights are the same, and as long as the area of the base is the same, you know that the prism, whether it's leaning to the side or standing straight up, is going to have the same volume. So let's do this one. When we're dealing with a rectangular prism, do yourself the favor of just automatically assuming that it's standing straight up. Consider the base face of this prism to be the one on the bottom, always, for a rectangular prism, so that way you don't have to think so hard, you know? Easier to deal with when you don't have to, like, be paralyzed by choice. There's 6 whole different faces. Which one should I pick? Pick the bottom one, all right? Find the area of this base. We've got 24 and 20, right? Length times width. 24 times 20 is 480. And then the height is the one that we haven't used, right? The height here is going to be 10. Then all we're going to do is do area of the base times the height. Get 4,800. And since we're doing volume, the units are going to be centimeters cubed. Volume is a three-dimensional measurement. It's measuring how much space we take up in the room, right? So 3 dimensions, so units cubed. Whether it's centimeters, inches, meters, miles, whatever, units cubed. Okay, so once again, find the area of the base, find the height. Our base face, again, it doesn't really technically matter, but if you use the bottom, then you don't have to think as hard. The two sides here are 5 and 3. So the area of the base is 15. The height is 4. So we just multiply 15 times 4 for our volume, and we end up with 60 feet cubed. Right? Pretty simple. And you know, I'm not saying you're always going to have to break it down like this. As I was walking around the room, many of you were not writing all this out, and that's totally fine. This is an organizational tool. If you need it, use it. And maybe as things get more complicated, it'll help to have it there. But you know, as long as you're getting the same answer with good work, you know that you're okay. All right, so now let's look at this triangular prism. And it says approximate volume, so it's just saying, hey, round. Now they don't tell us where to round, so we're rounding to 4 decimal places. But one other thing to see is that, all right, well, what's the shape of our base here? Well, we've got 8 inches, and this side is also 8 inches. So we're looking at an equilateral triangle, right? So rather than trying to figure out the height for some reason, just go back and use that 1/2 r squared sine 60. Well, what's r? It's 8. And I'm just going to leave it there for now. I'm not even going to bother, because that's going on the calculator, right? So let it be. What's our height? Now our height is the distance along the prism, right? From here to here. So this is our height. If it helps, if this is, because this is on its side, right? If it helps you to understand height better, redraw it. I mean, you don't have to, but if it helps you to remember, hey, height, right? Don't be afraid to do that. But you don't have to. If you sort of, you know, take the picture and, you know, identify, hey, here's the base, the distance from the base to the base, that's your height, right? It's up to you. However, you know, whatever helps. But either way, we go through, we've got our base, we've got our height. We're not going to try and do that out. We're going to put that in the calculator. So 1/2 of 8 squared times the sine of 60. That's our base, and then times 10. Don't forget to make sure your parentheses are in the right place. So we get 277.1281292. That's what I got out of my calculator. Make sure that you got the same thing, okay? Double check your work, because 9 times out of 10, people are going to make a mistake because they put the parentheses wrong or they didn't. So make sure that you're getting the same answer that I'm getting when you're doing these. And then after that, now we know we need to round. They don't tell us where, so we'll do 4 decimal places. 277.1 to a 1, and my units are inches squared. Right?
Isn't it cute?
Cute. Thank you. That was a test. Yes, inches cubed because we're dealing with volume, and volume is a 3-dimensional measurement. Your turn. Be careful because this is not an equilateral triangle anymore, right? So you're not using the 1/2 r squared sine of 60 anymore. Make sure you find the area of that triangle the appropriate way. Go over this. So once again, we're going to find the area of the base. We're going to find the height. Well, the area of the base, this is a triangle right here. So we're going to do 1/2 base height. I'm going to say, all right, 1/2 of 6 times 10, which is 30. And then our height here along the side of the prism is 5. And then we're going to do, for the volume, area of the base times the height. Our units are meters cubed. Again, you don't need to have a separate formula for a cylinder, but they provide it to you, so I'm going to give it to you because I'm not going to withhold stuff. But basically, what they give you, pi r squared h. This pi r squared, isn't that just the area of the base? Because the base is a circle. So it's the same thing. Area of the base times the height. If you want to use that, then you go on right ahead. It'll work just fine. It'll do the exact same thing you need it to. But I don't know. For me, more memorization means more things I have to keep in my head. I like to keep my brain smooth. No wrinkles. You're confused at what I wrote. So what I was saying with this page, you can use this formula if you want to for a cylinder, but you don't have to, because what I've been doing here, right? It's this. It's just they're trying to be specific to a circle for some reason, like it needs to be. This pi r squared is what the base is, what the area of the base is. So you could use this thing if you wanted to, but you already have this thing. That's the exact same thing. It's just a matter of, would you rather have to remember an extra formula or not? You know what I mean? So the formula that they're giving specifically for a cylinder, this, its own bespoke formula, is pi r squared times h. So let's do a cylinder. We are just going to find the area of the base. We're going to find the height, just like before. Well, what's r? Right here, it's 3, right? And then my height is 8. So I'm just going to b times h. 9 times 8 is, in fact, 72. And then centimeters, so centimeters cubed. All right. Again, don't overthink these. Here's your turn. Same problem. They give you a leaning one, but remember what I said about the leaning ones. You don't have to worry about the fact that they're leaning. It doesn't matter. Just treat it like it's standing straight up instead of leaning to the side. But what I told my first hour to do is just redraw it. Because it's the same exact thing, no matter how it's leaning. The key here is identifying the fact that that's a diameter that they give you, right? They point you right to the middle of it. So when you do this, make sure that you find the radius. Because that way when you do this, just get pi for the area of the base. The height is still 3. Like I said, it's the exact same problem. It's just they drew it messy to try and make you feel weird about it. My units are meters, and we're going to do cubed. This is volume. And that's all there is. Right? Find the area of the base, find the height, multiply those two things together, and get the volume. So lastly, like I was saying, these composite figures. So for both of these, you're going to notice it's a rectangular prism glued to half of a cylinder. So what we need to do is we need to be able to bust these up into their own specific pieces so that we can do these separately. Because that's all we're going to do. We're going to just hack it in half and then do them on their own. So I need the dimensions for both the rectangular prism and the half cylinder. So it doesn't matter which one you do first, but you got to figure out what you need to know. Because I've got 2 out of the 3 dimensions for the rectangular prism. I'm missing what this part actually is, right? The width of the base. But I do know the length of the entire thing from tip to tail. And I know that this right here, this 24, is also the diameter of the circle, right? Well, if the diameter is 24, what's the radius got to be? Just cut it in half. Right, this piece is 12. Well, if the radius is 12, this whole thing is 48, right? So this part's 12. What's left over for this part? Yeah, right? Part plus part equals whole. What plus 12 equals 48? 36 plus 12 equals 48. So we know that this piece right here is 36, right? Well, now we have everything we need. We know that for the rectangle, the area of the base is 24 by 36. The height is 24. And so we can figure out that the volume of that rectangular prism is whatever that multiplies out to be. 24 times 36 times 24, right? So we end up with this part is 20,736. And now let's find the other part. With that semi, I guess it would be like a semi-cylinder. Right? So for the area of the base, since it's a half of a circle and not a whole circle, right? So we're gonna do, instead of pi r squared, we're gonna do half pi r squared, right? I mean, or you could put the half in at the end. It'll work the same way, right? It's either, hey, I've got a prism with a base that's a half of a circle, or you could be like, hey, I've got a cylinder that's been cut in half. You're going to get the same answer either way, right? So it's up to you. Whichever way makes you happier, whichever way makes you feel better. Well, our radius is 12, so 12 squared divided by 2. I plug in 12 here, right? I better get 72 pi. And then my height is still the same, it's 24. So I get a volume here of whatever 72 times 24 is. Times 24 pi, 1,728 pi, right? And then from here, it's just a matter of adding it all together, right? Part plus part equals whole, right? How much?
I'm still trying to calculate this.
Oh, okay, cool. What you end up with is 26,164.67211. And it says nearest cubic inch, so we're gonna round, right? Final answer should be 26,165 cubic inches. Right? So once again, what did we do here? All we did was we took this apart, found the individual dimensions so that we could find the volume of one of them, find the volume of the other one, and then we just added them together and got our final answer. All right? Pretty simple, yeah? Especially once you break it apart. One of the big things I think that helps is to actively take the time to break things up into small little tiny tasks, because then you don't have to worry so much about doing everything at once, which a lot of times most books they're just sort of like, oh yeah, well, we're going to do it all together. But why, right? Why do that when you could just have life be easier and simpler?
I can't see.
My apologies, let me move. You know, let things be simpler. Let life be simple. One of my good friends from college he would always say, one disaster at a time. One at a time. You don't have to be a hero. The more you break things down, the faster everything feels like it's going, you know? All right, we feeling good? We copying? You good? Okay. All righty, here we go. Last one. Same idea, now it's a lunch box. You don't have to worry about the handle, you just have to worry about the lunch box. It may help you to remember that it is currently laying on its side from the perspective of being a prism, right? That may help. So let's go over this. Remember, we're trying to figure out the two pieces. In this diagram, you've actually been given all the information you could possibly need. You don't have to figure anything out, which is awesome. It's great. So let's start with the rectangular prism. You know, you can go through. It's going to depend on how you feel about it. I'm seeing it sitting on this face. If you turned it, it'll be sitting on the face that you put it on. You're going to get the same answer that I will, whether it's 10 times 6 and then the height is 6, or if you did the base is 6 times 6 and the height is 10. Either way, you better get a volume of 360, right? And then for the semi-cylinder, again, you know, that's 1/2. So we're gonna get, either like 9/2 pi or 4.5 pi, whichever you personally prefer. The height is 10 for this one. So 4.5 pi times 10, we get 45 pi. And then they're gonna ask you to figure out what that is to the nearest inch, so you can just do 360 plus 45 pi in the calculator, plus 45 pi, you should get 501, and then when we round it, it'll come out because it went to the nearest cubic inch. We get 501 inches cubed once you finish your rounding.